We're ready to make use of the newly created test account. We'll use the test account to compile and execute an application in an interactive session through the Resource Manager. We'll make use of OpenHPC's prun, which is a companion job launch utility. Prun abstracts the job launch complexities because OpenHPC can be run across different resource managers and MPI stacks. We'll be following section 6.1 of the OpenHPC recipe guide. On our console display, the leftmost columns are both the SMS host, and the rightmost columns will be the compute nodes. So let's take a dive from the SMS host. We'll begin by switching to our newly created test user. And because we want to monitor what's going on, we'll also need to switch to the test user on the bottom pane. We can see there's nothing in our home directory at the moment. We'll watch that, and we'll run mpicc watch the bottom left pane to see what happens after we compile. There's a new file, a.out. We're going to submit this job as an interactive job request and then use prun to launch the executable. We can query the Slurm Resource Manager with the command sinfo. This shows us that we have a partition with the name normal. It is currently up. It has two nodes, compute node 00 and compute node 01, in the state idle. That means that these compute nodes are ready to accept a job. We can also use a command sq to list what jobs are currently in the queue, and we will use a combination of these to watch sinfo and sq to observe what happens when we submit an interactive job to the Slurm Resource Manager. We'll now call an interactive job request for 8 processes or tasks on 2 nodes using bash. Now we can see here that these are in state idle, which means they're available for anyone to use, and there's nothing currently in the queue. When we run an interactive job request, it is submitted to the queue, and now those compute nodes are allocated. We are in a running state, and the user is test. That's us. We'll use prun, the OpenHPC tool that abstracts the complexity of submitting a job across a myriad of potential configurations in any HPC environment. And we'll be using prun to launch the compiled MPI Hello World example that we compiled earlier on. You can see the state is allocated and running in the queue. The state remains allocated and running once this task is completed because we are sitting in an interactive job. As is the nature of parallel execution, the ordering that we see here may differ the next time we launch the same executable, and we'll try it out. 7541, and you can see that the order is different. When we exit the interactive job, take note what happens on the Slurm queue and on the Slurm scheduler information. It's completing, and now those nodes are back as idle, which you recall means that they're ready to accept a new job.